In the second question, we are going to do the same thing. First, in the second question also, you write properly. Okay, this also they should give for 6 marks or 8 marks. So they give separately the question in your exam. Question number 1 they will give separately, and question number 2 also they will give you separately. So you have to write in details. None in your exam, don't write similarly B dash is this, similarly C dash is this, similarly D dash is this. Don't write this thing. Okay, don't write similarly. You have to show it. Okay, so you have to prove for all. Okay, so in question number 2 also, when they ask only question number 2 in exam, don't start from here. Okay, don't start from here. You have to, first of all, you have to find the coordinates of at the corners, because here we have mass at the corners. Okay, so you have to find the what coordinates at the corners, at each corner. So how many corners will be there? 1 2 3 4. Okay, 4 5 6 7 8, 8 corners. Okay, so we'll have 8 corners. In a cube we have 8 corners, so we'll have 8 corners. Okay, so you have to find alpha 1, alpha 2, alpha 3 till alpha 8, like how I've explained in the previous video. You have find in that way. After that, you try to find the moment of inertia of a cube. Okay, so how I have given you already. Don't do in this way. Okay, so I want you to write the notes of these two questions again. Okay, these two questions again. Don't write copy the same thing. I just give you the hint here. So this part you write as I have given you in your copy, in your notes, in the previous notes I have given you. So you write in the same way. You try to find the moment of inertia of a cube about its corner. Okay, so you get this. So first you do this one. After completing here, then you go back to this. Okay, then you go back to this. So you try to find, we can see here, we'll try to say first of all one more thing. You cannot go directly to here, so you have to look this part. You can, I'll show you here. There are how many masses at the corner we are taking as m by 24. So how many bodies are there? 8. Okay, plus what is the mass at the center? What is the mass at the centroid? We are taking the mass at the centroid to be 2m by 3. Okay, so we are taking the mass to be 2m by 3. So here you put 2m by 3 into 1. So one particle is there. So this will be 8 3 is that 24. So we get here, if we LCM we get 3. So m plus 2m. So this is equal to 3m divided by 3. So we get nothing but m. So here we get m. So that also you have to show. Okay, you have to show here. So you cannot go directly to a dash here. Okay, you cannot go directly to a dash. So first of all you have to show what is, you have to show this, what is the total mass. Okay, you proceed the same procedure what you have done here. You have to find the total mass of the system. So total mass of the system, by calculating here, okay, I get, when you calculate this one, we get the total mass of the system to be nothing but m. And in the same way they will have the same centroid, so you write this also. The two systems have the same mass, also the centroid of this particle at alpha I, and g is the point, G itself, which is the centroid of the cube. Okay, G is the point G itself, which is the centroid of the cube. So they have the same centroid. So we have also proof. We have to prove. Okay, because to show equimomental system, we have to prove that they have the same mass as well as they have the same centroid. So please, students, you drew by yourself in detail for all these two questions. Okay. So after doing this, you try to find a dash. So we know now coordinate of the centroids, coordinate at the corners. So that is alpha 1, alpha 2, alpha 3, alpha 4. You try to write this one. Okay, so you try to write in detail about this. So alpha 1 is how much, alpha 2 is how much, alpha 3 is how much. Then we get coordinate wise. Okay, then we'll try to find, here a is nothing but about the x-axis. So we have the formula summation m y square plus z square, and plus according to mass we'll have, so mass, okay, mass at the corner is m by 24. So you use this y square, coordinate wise you square and add, so we get this much, and so on for 8 particles. Okay, alpha 1, alpha 2, alpha 3, and alpha 4 separately you do this. And the mass at the centroid is 2 by 3m, and you know the y coordinate and z coordinate is a, so a squared plus a squared, we get 2a squared. So we get, if you simplify this, we are getting this one to be nothing but, we are getting here the mass of this. Okay, so the mass of this, we are getting nothing but 8 by 3 ma square. So we are getting here the mass of this is nothing but 8 by 3 ma square. So you try to get in that way. In the similar way, you try to find b double dash, c double dash, and so on, and d dash also you try to find, as we have done in the previous question. You try to find this, then we see that a double dash is same as a, b double dash is same as b, c double dash is same as c, d double dash is same as d, e double dash is same as e, and f double dash is same as f. So they have the same moment of inertia and product of inertia about the coordinate axis. By using polar axis theorem, we can also find the moment of inertia about the centroid G. So we can see that they will have the same moment of inertia about the centroid G also. So both the system, they have the same principal axis and the same principal moment of inertia about the centroid, and they also have the same mass and same centroid. So that's why these two systems are equimomental. So please student, do in detail for these two questions, and that will be your assignment also. So you please do this, and that will be your assignment. Thank you.